Hello and welcome to this PV Tech Talk series webinar co-hosted with GOODWE. The title of today's webinar is How String Inverters are Delivering LCOE Benefits for Large Modern Solar Farms. My name is Liam Stoker and I'll be your moderator for today's webinar. Now today's webinar will last around 40-45 minutes, featuring a presentation from GOODWE before a Q&A session. Our presenter today is David Sanchez, Sales Director for EMEA, Utility and Large Scale at GOODWE. But before we start, some housekeeping. Today's webinar will last approximately 40-45 minutes, as we've discussed, and after our presentations today, there will be a Q&A session, and we encourage any and all questions from our audience today. Questions can be submitted through the dialog box on your screen. The slides and the recording of today's webinar will also be available shortly after the presentation. But without any further ado, I'll hand over to David to begin today's webinar.
Thank you very much, Liam. Really appreciate it. Thank you for having me. It's a big pleasure. Thank you so much, everyone that joined today. This is David Sanchez, Sales Director for GOODWE EMEA. And we have an exciting webinar ahead of us. String inverters, LCOE, it's a very hot topic. So most of you guys face big challenges to make the numbers work, right? So we're going to talk a bit about string technology, LCOE, performance, and we're going to talk a bit about GOODWE. All right, so let's go for it. So the contents today will be, first off, we will start with a small introduction about GOODWE as a company. Then later we will move forward to the technology, right, to the innovation, to the real thing. And finally, we will discuss a bit about high quality, reliability, and service, which is basically part of the DNA of our company, of GOODWE. So first off, so as I said, GOODWE. So everybody knows GOODWE by now. So it's a tier one solar inverter manufacturer with headquarters in Suzhou, right? So we are the inverter manufacturer with the biggest growth in the last years. So it's already more than 3,000 employees, more than 600 R&D staff dedicated to our solar business, more than 150 overseas employees. But what is really impressive is the evolution of the revenue, as you can see, right-hand side. So roughly 2019, 150 million, 2020, 250 million USD. Last year, already 410 million USD. And the expectations for this year is having the same amazing growth, right? So this is not for no reason. It's because we have a very bankable company and a high quality product. Actually, according to recently published market reports, GOODWE is already number 5 in terms of the rank of PV suppliers globally, right? So this shows what kind of company GOODWE is. And for sure, a clean energy world. This is our vision. This is our target. I think we all share this same target. This is why we work for, right? So we try to deliver high quality PV solutions to try to help the world, to try to help moving towards a more clean world, a greener world. Global presence. So this is a very key part of GOODWE's business. So we have developed the business globally. We are present in every single continent, in most of the countries, through APAC, through EMEA, through LATAM, USA, Africa. We are there, right? So we understand that's a very important part of supporting our customers with a strong local presence. Bankability, very important thing. So we are very proud to share that last year's report from Bloomberg in 2021 shows that GOODWE is actually the publicly listed manufacturer with the best bankability rating, right? So let me please remind that bankability is not only financial, which it is, but also the sustainability of the company, R&D, etc., etc. So we are very proud of this recognition from Bloomberg, and that shows again what kind of company GOODWE is, with a really high bankability and really high quality products. And our portfolio. So we are also very proud to say that we are the inverter manufacturer with the widest inverter portfolio. So from residential to utility, we have so many models with so different features. And again, we are proud of it because this is part of what we are, right? We know about manufacturing solar inverters and about delivering high quality solar inverters. And again, the widest portfolio in the market is held by GOODWE. As to global installations, so more than 36 gigas installed globally, 1 giga for energy storage, 19 gigas for CNI, 15 gigas for residential, massive success. But also we are achieving a massive success also with our utility business. More than 2 gigas of utility scale project being delivered or under delivered. That shows again that customers are actually looking forward for new suppliers and new technology that can actually deliver innovation and lower LCOE. And this is GOODWE is achieving a massive success globally. Okay, so let's move forward to the technology, the real thing. Okay, so this is our GOODWE 200 kHT inverter. Okay, our utility scale inverter. It's a multi-MPPT inverter. Okay, we will discuss a bit later about the benefits of the multi-MPPT topology. 800 volt AC, 99% maximum efficiency, PID recovery, IV curve, Q at night, late temperature derating. Please keep that in mind. This is one of the features that we are actually bringing to the market and brings massive LCOE benefits for short ease installation and O&M, power line communication, etc., etc. So first off, the topology. So this is the topology of the string inverter solution. As you can see, it's very simple, it's very digital, it's very smart. So basically, a string do connect directly to the inverter. The inverter has a maximum of 12 MPPTs for the K version, 6 MPPTs for the KM version. The only difference is the adaptability to high current modules, right? So in any case, 2 strings per MPPT or 3 strings per MPPT do connect directly to the inverter, from the inverter directly to the transformer, right? So very simple topology, no AC combiner box whatsoever. So when we're talking about LCOE, right? So LCOE, there are 3 main factors that actually have a big impact on LCOE. One is Capex, the other is Opex, and finally generation, right? So if we attack all 3 parameters, we are actually able to optimize LCOE. So let's first stop a bit on BOS, on Capex. So when using string topology, string inverters, there is a clear saving as to Capex, as to BOS, right? So as I mentioned, the strings do connect directly to the inverter, and the inverter goes directly to the transformer. There is no kind of AC box whatsoever. When comparing to centralized solution, you still need to go through string boxes, etc., right? So instantly, you have a big saving as to BOS, 0.5%, 0.4, but a massive saving as to BOS only due to components. But then also you need to consider that you don't need a big foundation for the inverter. Then you have also some civil savings, right? But also you can also consider that you will have also some labor savings, cable saving. So totally consider there is a big saving as to BOS when compared to central solution. Multi-MPPT topology, as I said, so this is critical. This is a fundamental thing. So, and this makes a big difference again when talking against central inverters. So mismatch losses is a thing that has always been an issue on site, but since bifacial modules are becoming mainstream, the mismatch losses are even more important than they were before, right? So only with the multi-MPPT topology, you can actually take the most out of bifacial modules. And that makes sense, right? Because bifacial, there is a huge uncertainty when it comes to the rear side, when it comes to the albedo. So 2 tables that can be together, only distant 10 meters, can actually have different IV profiles, right? So let alone strings that can be distant for 400 meters. So this is why central solution, normally they have 400 strings, 300 strings going to 1 MPPT. When you design with a string solution, you have 2 strings or 3 strings going to 1 MPPT. Actually, this is the only way to take the most out of bifacial inverter, because 400 different IV profiles will influence and will impact the other, right? So only having the minimum possible amount of strings per MPPT, you can actually maximize the performance of bifacial modules. So this is where multi-MPPT topology is actually changing the market, right? So in my opinion, central inverters will have to probably bring a different concept, because with bifacial modules, only with multi-MPPT topology, you can actually get the maximum possible performance of bifacial modules, right? In our case, as I said, our K version, 12 MPPTs, our KM version, 6 MPPTs. Availability. This is somehow a no-brainer. So the highest the availability, the highest the generation side, right? And this is where string inverters bring a massive value differentiation. So when you have a string inverters on site, first off, the failure rate will be a bit lower than central inverters. But most especially when an inverter do fail, you are losing only 250 kilowatt, right? So the impact on availability is very limited. And not only this, but if you have some spare parts on site, you can quickly replace the faulty inverter by a new one, and you will keep the availability at its maximums, right? So this is very linked to the string topology. When compared to central inverter, they normally have a higher failure rate. These are machines that actually manage 4,000, 5,000 amps. It's a high amount of amperes. Then when an inverter fails, for sure, you need to call the technician. You will lose 3 megas, 4 megas, 6 megas for a certain time, few days probably. And you have a high dependence on OEM service, right? So when string inverters fail, you can replace them. It's very easy. You don't need to be a skill for that. It's just replacing DC and AC. For central inverters, you actually need a technician to come on site, perform all the corrective measures, etc., etc. So when it comes to availability, big difference. It's no surprise that string inverter solution actually managed to have 99.9 availability, right? So it's quite easy because the concept is actually meant to minimize the failure rate and to maximize the availability on site. Advanced thermal design. Again, this is probably one of the most important things that GOODWE is bringing to the market. And actually, this is a big differentiation when it comes also to understanding a string against string solution, right? So we are bringing probably what is the best derating curve in the market. So we keep 250 kilowatt from 25 degrees to 40 degrees. No derating whatsoever up to 40 degrees. So this is a massive thing. Me, myself, as an engineer, I found this amazing. And not only this has a massive impact on the performance, on the lifespan of the inverter, but has a direct implication on the LCOE. If you are not, if you don't need to apply any derating up to 40 degrees, and we know very well throughout APAC, EMEA, LATAM, United States, 40 degrees is a very, very, very common design temperature, right? So when comparing to other solutions, most of them will actually apply a derating from 30 degrees. We don't apply any derating until 40 degrees plus, right? So you will have instantly less units, right? Maybe 6-7% less units on site because you don't have any derating, but also that will have a massive impact on the O&M, on the generation. As I said, this is a massive feature that will actually bring down LCOE instantly. And this is one of the things that our customers actually find most attractive from GOODWE inverter. High efficiency, for sure, it's a high efficiency inverter, different voltages, different loads, very, very high performance. But what I like to show about this slide is actually the following slide, which is our DC booster. Probably one of the best innovations in the market. And instantly you can see that our MPPT range goes from 500 volt to 1500 volt this year, right? Normally, when comparing to central inverter, you will have something like 850 volt to 1300 volt or 900 to 1200, something like that, right? And this is why. This is because they don't have a DC booster. So the DC booster is a DC source that we widen the MPPT range, right? So first of all, generation. So first thing in the morning, latest thing in the afternoon, okay? First thing in the morning, the sun will start coming up. The voltage will start to go up, 200, 300, 400, 500 volts. Our string solution is already generating. Central solution will take a bit more until the voltage is somehow 800 or 900 volt DC, right? So instant generation that you bring to your pocket, instant money that you bring to your pocket. Sorry about that. The same thing in the afternoon. In the afternoon, when the sun goes down, central inverters will switch off before, and we will keep generating for a few minutes more. Again, extra generation that goes into your pocket. But not only it's a generation thing. So the fact that we include a DC booster, okay, also helps the DC link inside inverter to be more stable. And what is the consequence of that? The consequence of that is that we are able to have an IGBT switching frequency of 16 kilohertz. Normally, central inverters do bring 3 kilohertz, 4 kilohertz, the maximum, right? So what is the difference? The highest the switching frequency, the highest the quality of the wave, and therefore the lowest the harmonics. So again, first, it's a generation plus, but it's also bringing higher quality of the wave and less harmonics, which again is also a massive topic in every single region. But not only this, this booster will also help to comply better with grid codes, right? Because when you need to actually supply some reactive needs, the voltage at AC terminals might be a little bit higher, and therefore you might be required to have a lower voltage DC to start the inverter, right? when it comes to having a DC booster, the famous QVDC curve does not apply, right? So first off, generation, but also stability of the DC link and switching frequency, and finally, better grid code compliance. So the DC booster is a massive innovation that brings massive benefits to our customers. But it's important to highlight that not all the DC boosters included in the string solutions are the same. So every single brand has an efficiency for the DC booster and has a performance for the DC booster. In our case, it's a highly performant DC booster, and you are always able to take the max out of the modules. In the case of bifacial, as I said, even more, right? So not all the string solution had the DC booster. This is something that really needs to be analyzed before deciding inverter solution. High temperatures. This is a very common challenge that most of the customers are facing, right? So when it comes to high temperature, inverter performance can be a thing to actually check. Also the voltage on site. And this is what I'm linking also with previous slides. So the rating curve, as I said, no derating up to 40 degrees. So massive saving as to LCOE, massive savings as to BOS, massive boost of performance because of non derating up to 40 degrees. But also the MPPT range. So everybody knows the higher the temperature, the lower the voltage. So the voltage will displace a little bit to the left. So again, having a DC booster makes a massive difference when comparing to other solutions, because under high temperature scenario will perform way better. PID recovery function, anti-PID function. So again, this is a very hot topic these days. Yes, most of the module manufacturers, they can guarantee PID-free modules. This is absolutely clear. But it's also true that many technical advisors, many funds, many customers are actually requesting for the inverters to have a PID recovery function or anti-PID recovery function, right? So again, this is quite important. So basically the concept is very simple. So the inverter will actually generate reverse voltage in the AC side. Since the inverters do not have galvanic insulation, this voltage will move to DC and will keep the voltage at the negative pole close to zero. This way you prevent and you recover the PID degradation. Again, this leads to lower O&M, lower Capex, lower LCOE. Solid grid connection support. Again, that's a no-brainer. So we all know that all the grid codes are getting more and more challenging. All the grid operators are toughening the requirements in every single country. So when selecting an inverter manufacturer, it's very important to understand, do they have the proper capabilities to actually cope with the grid code requirements, as to fall right through, as to reactive generation, as to supporting a very low short circuit ratio that we find more and more, because the massive penetration of renewable are actually bringing down the short circuit ratio, right? So when it comes to selecting the proper inverter brand, it's very important to understand all the grid support capabilities that inverter need to bring, because again, the solar farms are becoming the more and more challenging and the more and more technically complex. And it's very important for the heart of the solar farm, which is the inverter, to actually be able to cope with all these requirements. PLI communication. So probably you already know about this solution. It's actually a massive innovation in the solar market. So you don't need a communication cable anymore, right? So you don't need RS-45 anymore. If you don't want, for sure you can use it. It's always included in the inverters, but if you want, you don't need to use it. Why? Because all the inverters will have what is called the PLC feature, which is basically every inverter will include a chip inside the inverter that will generate a high frequency signal. This high frequency signal will run through the AC cable. Okay, all the power will go to the transformer, and all monitoring will be filtered by the SCB3000, which is our communication box. Okay, so basically you will have string level monitoring without one single comms cable. Again, this helps to bring down the LCOE. This brings a lower BOS, right? And not only this, but also a simpler, smart, and digital solution. When us suppliers, we talk about smart, we talk about digital, this is what we're talking about, right? Trying to minimize the resources on site, try to minimize O&M, try to minimize the human presence on site, right? Because this is where the market, the industry is going. Is installation. That can be easily understood. When comparing to centralized solution, you need cranes, you need actually to move around big machines that have a massive weight. way simpler when we talk about string inverters, right? So it's a box that can be lifted by 2 people, maybe 3 people. You connect it under the module structure or in a pile in the main L, and it's so easy to move around, it's so easy to manage, right? So there will be a big labor saving compared to centralized solutions. Easy commissioning for sure. So every single inverter will include a USB stick. So you can just go and monitor every inverter individually, set all the parameters individually, do the commissioning individually. You can either do this, you can also go to the logger and actually perform all the setting to all the inverters downstream this very same logger, right? So in the end, let me please repeat myself, smart digital. This is where we are going. We are trying to minimize the human presence on site so the LCOE can be as lower as possible. Multiple inverter connectivity. So how does the connectivity in a solar farm work? As I explained, so all the inverters will connect to one logger per transformer station. The communication, the string level monitoring will be actually achieved through PLC, so no comms cable whatsoever. And then you will have all the loggers at transformer station level connected through the fiber optic ring, right? So again, quite simple and something that is not complex, and you probably know about it. AFCI, so Arc Full Circuit Interrupter. This is also an amazing feature. So this is a protection feature. This comes from the UL, this comes from the US, and GOODWE is actually bringing this feature also in our utility scale inverters. As far as I know, I think we are the only inverter manufacturer bringing this amazing feature to the utility inverters. And I say amazing because it's actually really, really good when it comes to preventing issues, big issues on site. So as we know, the DC arc can be really dangerous as to fires, as to issues with people or with equipment. So basically the FCI is a feature that if the inverter, if the electronics actually detect that a DC arc is being created, will shut down instantly the inverter to avoid any fire, any issue with people, any issue with the equipment, right? So less than 0.5 seconds, and it will bring the voltage to zero. Again, massive feature. We are very happy to include this in our inverters because AFCI is becoming the more and more demanding. And actually, it's an extra redundant protection, right? Which is always excellent. We're talking about big solar farms. Integrated protection for maximum uptime. So as I said, we manufacture high quality inverters, and for that you need high quality protection features, right? So there is a long list, as you can see, about the features that our inverter actually bring to the market, including, as I said, AFCI and PID recovery. So all these protection measures only lead to trying to lower the inverter being off, trying to maximize the inverter being as safe as possible, and in the end, trying to deliver the highest quality and the highest possible safety to our customers. IV curve diagnosis, smart IV curve diagnosis. This is an amazing thing. Myself as an engineer, I found this absolutely brilliant. And again, as we were discussing, so every day the tenders are getting the more and more challenging. LCOE is going down, and the more and more O&M is actually having a very, very important role to be able to achieve lower LCOE, right? Sorry. So how does IV curve, smart IV curve diagnosis work? So basically, the system, okay, on the inverters will have a database of all the theoretical IV curve from the PV modules, right? Since the inverter has capacitor, has resistance, is actually able to vary both current and voltage, right? So the inverter will actually obtain the real IV curve. We'll compare both patterns, and depending on the outcome of this comparison, we'll tell you, okay, the strings are good, or there is a problem with what string. As you can see right-hand side, so it will be basically comparing patterns of the theoretical and the real. So let's for example assume we have a 50 mega solar farm. 50 mega solar farm. This is roughly, generally speaking, 5,000 strings, right? So you run from your phone. The system, in probably 10 minutes, you will have the whole report, and it will tell you, all right, so you have 4,985 strings fully healthy. Excellent, very good. But you have 15 strings with some kind of problem. So the system will tell you what is the problem. There is a diode broken, there is some shading, there is some bad connection, and it will propose some troubleshooting to actually fix that. So just imagine the amount of resources that you will save with this kind of digital tool, right? So you don't need to go on site anymore with the machine and maybe perform a 10-15% of the solar farm in 2 weeks. This is over. Again, digital, smart, try to minimize the human presence on site. This is the only way to actually bring down the LCOE, and this is why we are actually bringing our smart IV curve diagnosis. Our transformer station, so we deliver our inverters together with our transformer station. Just roughly to speak here for a second. So we are bringing a 7 MVA transformer station, which we believe is quite optimal as to Capex and as to design on site, quite flexible with all scenarios. And again, not only 7 MVAs we are bringing, also lower capacity, but we go up to 7 MVAs, which is 28 inverters connected to the transformer, 14 to one winding and 14 to other winding. And finally, GOODWE's high quality recognition. So that's a very important thing that I like to stop for a second here. Why? Because in the end, probably every sales guy that you come across will tell you, yeah, my brand is the best, is the high quality, which is fair enough. But the reality is that we have some backup as to actually saying that we have a high quality recognition. So throughout the last years, several third parties have actually highlighted GOODWE's design. Has said, hey, GOODWE, they have a really high quality design, they have a high quality R&D investment, they have a high quality product, right? So Euro Research, TÜV Rheinland, also Bloomberg last year highlighting our bankability. So the reality is that throughout the last years, many third parties, global and very well-known third parties, are actually highlighting how good our inverters are, how good our technology is, and how good our company is, for sure, right? So again, we are very proud of that, and as I said, it's part of the DNA of our company. And obviously, so a high reliable inverter can only come if you use a high quality R&D design, but also high quality components, right? So this is clear. So we are very proud that we are actually able to buy, to source ourselves globally, right? So we work with the best. Wherever the best is, we go and we try to work with them and source from their components. Germany, United States, Japan. Again, we only look for the best components because this is the way we understand we can guarantee the highest quality for our customers and for our products. And obviously, all inverters go through very demanding laboratory tests, right? So as to temperature, as to noise, IP, aging. Again, this is not no-brainer. Only with the highly demanding laboratory test, only with the high-quality component sourcing, you can actually deliver a high-quality inverter. And yeah, finally, I think it's only a couple of slides more. So the dynamic model. So as explained, so the grid codes are getting very challenging. So most of the grid operators, they require support as to the Silent, as to PSSE. So for sure, if you need any support on that way, let us know. We have a very experienced team, very highly skilled team as to system modeling. And we'll be happy to support you guys, okay? But yeah, we understand how important this is these days when discussing with grid operators, especially in certain markets. And for sure, we can deliver this support and we can deliver the software and the models. Finally, yeah, we have a dedicated utility team support. So throughout EMEA, APAC, United States, LATAM, we have an experienced team of very skilled people with years and years of experience in this utility business. And we are very happy to actually offer and bring our support to customers, right? So no matter if it is PVCs, or if it is simulation, or if it is LCOE calculation. So we will always be happy to support. As I said, we have a highly skilled team of engineers and experienced people, and we will always be happy to supply this support to our customers. And finally, first off, thank you so very much for attending the slides. I hope you find this interesting. And finally, let me please show our beautiful new logo. Probably you see that everywhere these days. So yeah, looking forward to welcoming you to the GOODWE family. So thank you very much, Liam. I think we can move forward to the Q&A.
Excellent. Well, thank you, David, for the presentation. As David has said, now's the time for you in the audience to pose your questions to David. A quick reminder that you can submit your questions via the dialog box on your screen that you can see there to your right. David, we've got a couple of questions here just ahead of time. With the range of inverters that you've demonstrated today, how does the performance of those inverters compare to other string inverters that are on the market today, and that kind of designed and optimized to work under those high temperatures that you spoke about?
Excellent question. Thank you, Liam. Yeah, there are clear benefits, right? So as I said, we can discuss string against central solution, but when we discuss string against string, not all the solutions perform the same. Not all the solutions, they include the same technology. So first of all, as to high temperature scenario, as I explained, so GOODWE 250 HT inverter does not apply any derating up to 40 degrees. Instantly, that's a massive benefit compared to other string solutions. Most of them from 30 degrees and on, they start derating, right? So just the fact that we don't apply any derating up to 40 degrees, it's massive, massive, massive advantage compared to other string solutions. So again, this is something that needs to be analyzed when trying to compare string solutions. But not only this, not only not only bringing the best derating curve is the only benefit. When comparing also the DC booster performance, not all the string inverters do bring the same performance for the DC booster. Yes, all the string inverters probably they have a MPPT range from 500 to 1500 volt DC, but what you need to analyze is what is the maximum capacity compared to the nominal power that the booster is actually being able to extract, right? So again, the DC booster, the efficiency and the switching of the DC booster is also a point that our customers need to actually stop by for a second and analyze when comparing string against string.
Okay, great, fantastic. We've had a couple of questions from the audience today targeted specifically at the DC booster that you've spoken about. Could you perhaps explain a bit more about the benefits of that, go into a bit more detail around the actual kind of power output that they provide?
Yeah, absolutely. So for me, as I explained, and I know that I stopped on the DC booster for a few minutes because for me, it's a massive innovation. It's a massive technical advantage. So as I said, so first off, you have the generation extra, the extra generation, right? This is money to your pocket. So, and this is always reflected on the O&D for sure. So first of all, you will have a higher generation, okay? But second, and very important, a bit more technical, very important, the IGBTs are able to switch at 16 kilohertz. 16 kilohertz means way better quality of the wave and less harmonics. Harmonics is a topic that it's important in every single country, in every single market, but there are certain places where harmonics is really, really a nightmare. Trying to use and trying to design with a solution that brings less harmonics, I think is a smart thing to do. So as I said, generation, harmonics, but also grid code compliance. Normally, grid codes will require reactive to be generated at inverter level. So this will bring a bit up the voltage at AC terminal, which with other solution, it can complicate the compliance of grid code, right? Because the inverter will not be able to start at 850, 900 volt DC, right? So having a string DC booster allows also to have a way better compliance with when the grid codes. For example, all our customers can understand the famous curve reactive to voltage DC. This is not applying when using a DC booster because it's not as limiting the generation of reactive with the starting voltage in the DC side.
Excellent. Now, we've had a couple of questions just checking on products availability, kind of lead times. Is there any kind of indication you can give on those? Is the product available now? How long are developers likely to be expecting these products for?
That's a great question. So yeah, most of our customers are suffering these days for a very volatile and complex market. Okay, so as to inverters, as to transformers. But anyway, this is a topic that probably if you contact directly with myself or any of GOODWE team, we will be able to give a more accurate discussion because for sure it depends on project by project, location and schedule requirements, etc., etc.
Fantastic. And Another quite pressing topic for the industry is the carbon footprint of manufacture. Is that information available from GOODWE?
Yes, absolutely. Actually, GOODWE is a publicly listed company, so it's quite transparent in that way, and most of the things are available for the public and our customers. Yeah, for sure.
Excellent. Another pressing detail, a couple of people have asked about it on today's webinar already. Could you perhaps elaborate a bit more on the benefits of the GOODWE 250K HT range when you are using bifacial modules? Obviously, bifacial a lot more creeping into projects now, so it's a key pressing topic for the inverter selection as well.
Yeah, absolutely. And again, it's one of the main reasons to actually choose a string inverter against a centralized solution, right? Why? Because, as I explained, so first off, bifacial modules are already very mainstream, right? So it's, I would say, and again, this is a rough figure, but I would say that 80–90% of the solar farms globally are already built with bifacial modules, right? So when discussing about bifacial modules and inverters, we need to understand that the bifacial module, though it brings a higher performance, it also brings a higher uncertainty when it comes to the real side generation, right? So albedo is a very difficult thing to actually control. So two tables that can be one close to the other can have different albedo, right? And different albedo will lead to different generation in the rear side. So this will lead to different IV profiles, right? So it doesn't make sense, or it doesn't make too much sense from a performance optimizing point of view to actually put together 400, 300 strings, because we know that one string will influence the other, right? So it doesn't make much sense to actually put together 300, 400, 500 strings in one single MPPT. On the other side, our solution, GOODWE solution, has 2 strings per MPPT in the K version, 3 strings per MPPT in the KM version, right? So the concept behind this is, since bifacial are bringing a huge uncertainty, the more MPPTs on site, the way better. So this is where having a solution like ours, 12 MPPT per inverter or 6 MPPT per inverter, you will find yourself with hundreds of MPPTs on site. This is the only way to actually take the most out of bifacial models. But again, I'm so happy to discuss about this topic with whoever raised the question and any customer. Again, is one of the most important value differentiation when comparing string inverters to center inverters.
Excellent. And I think we've got time for one more. I'm just going to pick some, going to try to tie in a few questions that we've had from the audience today. David, could you perhaps go into a bit more detail around the grid forming capabilities of the inverters demonstrated today? Is that something that you have? Is that something that you're keen to discuss outside?
Yeah, sure. So, yeah, sure. So basically, this is probably the next leap, the next technology that will be mainstream when it comes to inverters, probably throughout the next 5 years, right? So probably as of now, as of today, is not the priority of the market, but it will be, because again, we are talking about a grid that is getting weaker and weaker. Okay, the massive penetration of renewable energies are bringing down the short circuit ratio. But also we are seeing a massive increase, and we will see a massive increase of the grid forming capabilities and requirements globally. There are some countries like Australia and other islands where this is a bit more developed, right? A bit more urgent, let's say. But we will also bring, not now, because again, we don't think this is something that as of now in 2022 is extremely required by the market, but probably by next year we will also bring other solution with the next technology, because this is where the market is going. Grid forming inverters that are able to supply frequency and voltage instead of only P and Q, and utility storage, right? Which again, throughout the next 4 or 5 years will be a solution that will be quite accepted and quite developed globally.
Fantastic. Well, unfortunately, that is all we have time for today. Of course, as we've said throughout, the presentations and the recording will be available shortly, both on PV Tech and in your inbox, so keep your eyes peeled for those. A huge thank you to GOODWE for supporting the webinar today, and to David for presenting and taking all of your questions, and indeed all of you for your attention. Thanks again, and we hope to see you next time.